Welcome to Pacific Science Center. My name is Zita, and today I'm thinking about animals. Now, a lot of times when a scientist wants to learn about an animal, they can go and make direct observations of that animal. They can go out and they can watch it, and they can see what it interacts with, what it eats, what it drinks, and how it lives. But what do you do when the animals that you want to learn about don't live here anymore and are dinosaurs and have gone extinct millions of years ago? Well, a key way is through fossil evidence. Let's take a look. So there are several different categories of fossils, and it's all based on how that fossil forms. All right, let's imagine how this works. So imagine that you've got some muddy, sandy area, and you have an animal, like a shell perhaps, that maybe lands and falls and sinks to the bottom of that muddy area, and it gets squished in to that squishy mud. Now eventually this squishy mud will dry out and it will harden and it will turn into a rock, and the shell may dissolve away. And what you have left is an impression in this rock, the exact size and shape of what that animal was. This is called a mold fossil because it's left a mold in the rock of that animal. Now, sometimes a natural process might happen thousands of years later where new sand or fresh mud might fill this in and might actually harden into a rock itself. It then is a rock that is exactly the size and the shape of what this original animal looked like. That's what's called a cast fossil. And this is an example of a cast fossil as well, where it is a rock. There's no organic material left, but it's the exact size and shape of this original animal. Now, sometimes a scientist or a paleontologist might find a mold like this. They can fill it in with plaster, let that plaster dry, and then when they pull it out, they have a 3D representation of what that original animal looked like. And they've made a cast themselves. Now, the third main kind is called a trace fossil, because this isn't actually part of the animal itself, but is evidence of where the animal was. So, for example, you could have, once again, imagine a soft, squishy ground, and a dinosaur comes along and leaves a footprint. The dinosaur leaves, but you have that footprint left behind. That footprint can then get filled in with some more sand that hardens, leaving an exact model of what that foot size and shape was. Now, another type of trace fossil, one of my favorites is this. What do you think it looks like? If you're thinking what I'm thinking, you're right, it does look like that. This is a coprolite, and it's actually leftover scat, or poop, from that animal. In fact, the word coprolite comes from the Greek kopro and lite, which basically means dung stone. It's a poop stone. Now, they may look funny, but they're actually really important, and scientists can learn a lot about the animal that left this behind as a trace. They can learn what the animal ate, and they can learn what the chemical composition maybe even was of some of those plants that it was eating. So, silly looking fossil, but very important to scientists. All right, so one of the best fossils that we can study as a paleontologist or a person that studies fossils from a long time ago and learn about those animals is a direct skeleton like this one. Now, this is a skull of an animal called a Deinonychus. And a Deinonychus is a dinosaur, lived many, many years ago. This is an actual skull from one. And looking at this skull, we can learn a lot about what this animal was like. We can look at its teeth, very, very sharp teeth, both along the bottom and the top. And we know that this was a carnivore or a meat-eating dinosaur. We can look at the location of its eyes and see that the eye sockets are both in the front of the head and facing forward. This allows the eyesight from the right eye and from the left eye to actually overlap a little bit, providing stereo vision, binocular vision, meaning it had really good depth perception. That depth perception is really important for a carnivore that is hunting another animal. You need to know where that animal is so you can reach out and claw it and grab it. If you were an animal that was a prey animal or an animal that was likely to be eaten, you would have your eyes located more on the side of your head, allowing you to see if anything was trying to sneak up on you. So that's just a couple of examples of how we can use fossils like this to learn about animals that lived a long time ago.